challenging problems. Three circles with centers A, B, and C are externally tangent to each other as shown. Lines EG and DG are tangent to circle C at points F and D and intersect at point G. If each circle has a diameter of 6 inches, find the length DG and the area enclosed by lines FG and GD and arc FD. So we are given with this figure. Okay, so we're gonna use this figure as our given. Okay, so let's write the given. Okay, so given the diameter, this one, so diameter A is equal to 6 inches. Diameter B is equal also to 6 inches. And diameter C is also equivalent to 6 inches. Okay, so part of that, we're only given that EG and GD are tangent to circle C and that the circles A, B, and C are tangent to each other. So the keyword here is, apart from the measurement, is the given fact that the circles and the lines are tangent. So remember that circles and lines that are tangent to another has some properties that we can use. Okay, so we will talk about that later on. Okay, so let's have the required. So for this problem, there are actually two required measurements. The first one is the length DG. So we're just gonna write DG here. And then the second one is the area enclosed by the lines FG, GD, and arc FD. So let's locate that one. This one is FG, GD, and arc FD. So the problem pertains to this portion of the figure. So we will label that one for convenience purposes as A. Okay, so let's label that one as A. So let's name this one A. Okay, so for our solution, okay, so first let's solve for DG. Okay, so the first step of our solution is to create a triangle EDG. Now we can create this triangle because of the given fact that first is the three circles are tangent to each other. So with that, we can draw a line from point E all the way to point D, connecting the centers A, B, and C. Next is angle D is equivalent to 90 degrees because remember that DG is tangent to circle C and that tangent lines are perpendicular to the radius at the point of tangent C. CD is a radius and D is the point of tangent C. So therefore, CD is perpendicular to DG and remember CD is part of the bigger segment ED. Okay. So notice that apart from the 18 inches length of ED and the fact that angle D is 90 degrees, we could not find any more measurements that will enable us to solve for DG in this figure. So we need another figure that will at least enable us to find some more measurements in triangle EDG that will in turn help us solve for the segment DG length. Okay, so another possible triangle that we can use or figure is triangle EFC. So let me draw that for you here. Triangle EFC. Okay, so how is this triangle possible? Again, it's the same concept with triangle EDG. F is the point of tangent C. with circle C, and of course CF is also a radius, so they also form a 90-degree angle similar with DG and CD. Then EC is part of the bigger segment ED, so we can also have that segment as well. Okay, then we can have some measurements. So CF is the radius of circle C, so therefore its measure is 3 inches. Okay, next is EC is just the length of EC is just the sum of the diameters of circle A and circle B plus the radius at circle C, so that's 6 plus 6 plus 3, or that is 15 inches. Okay, now how can we use this triangle EFC to solve something some measurements with EDG? Notice that both of these triangles share the same angle E. So if we can solve for angle E in triangle EFC, then we have as well solved for angle E in triangle EDG, which will now enable us to solve for DG. So to solve for E, we can use the SOHCAHTOA in triangle EFC. So notice that with respect to angle E, EFC is the opposite side and EC is the hypotenuse. So with that, we can use the sine function. Okay, so sine of EC, so rather sine E is equivalent to opposite 3 over 15. Therefore, we can solve for measurement of angle E using the arcsine function. Sine -1 of 3 over 15, which will give us a value of 11.54 degrees. Okay, so we can use this value 11.54 degrees on the triangle EDG. So here we have angle E, which is already known as 11.54 degrees. DG is opposite side with respect to this triangle, and 18 inches here is the adjacent side. So we can use the tangent function. So tangent of angle E, which is 11.54 degrees, is equivalent to opposite, which is DG, and adjacent, which is 18. So DG therefore is 18 tangent of 11.54 degrees, or DG is equivalent to 3.67 inches.